Hi kids, this video is going to replace the one that I posted yesterday going over the probability notes. Sorry that there was no sound. I didn't realize it at the time, but this one hopefully will work better. Okay, so we're going to talk about probability. And there are a couple of things I need you to know. You can take the pages that we sent home in your packet, like this one, the ones that are labeled notes. You can cut those out and put them in a field manual so that you'll have those to use when we do our practice problems, or you can use those on a test, or you can just kind of write on them and hold on to them in one packet. Just keep them all together. And then make sure you're working on your practice problems along with these notes. Okay. Also, there is vocabulary that is posted in Quizlet for this unit. It's called Probability and Statistics. That's linked on the pathway. And we'll try to get together on Thursday and do a Quizlet live session. So at our 2 o'clock Zoom meeting session on Thursday, hopefully we will be able to do the Quizlet live if everybody can get logged in. Okay. So I want to start out by kind of relating probability to the stuff that we were doing in science. If you'll remember, when we were in school, the last few classes that we had looked at Punnett squares. We had started doing some that looked like this, and we did those crosses. We talked in terms of what is the likelihood of a particular outcome when we're looking at offspring. Okay, so if you remember going over this, we are actually using the probability. We're talking about the likelihood that an event will occur. So if you need to take a look back at your vocabulary, that the vocabulary in science, that might be pretty helpful. And I'll do another video. We've done the video with the Punnett squares, just kind of get familiar with the vocabulary that we're going to be using. Okay. So if this were, if this were our Punnett square, and we have two heterozygous parents, that means that both parents have a dominant and recessive gene. We'll say this is for brown fur. Okay. If the dominant allele, the big B, was for brown fur, and the little b was for, we'll say, white fur, okay, we'll look at what the probability that the offspring would have either brown or white fur. Okay, so the first one, if we look, and remember, when we do the cross of the big B, we get a homozygous dominant trait. That means that this is going to be homozygous dominant for brown fur. And in this particular cross, there is only 1 out of 4 chance that the offspring will have a homozygous dominant trait, which translates into a 25% chance. Okay, that's where probability comes in. What is the likelihood that this will occur? For this particular trait, there is a 1 out of 4 chance that that trait will be the one expressed. Okay, now what is the probability? What is the probability or the likelihood that the offspring will have white fur? Well, remember, in order to have white fur, it must be homozygous recessive. Okay, and that shows up 1 time. So there is 1 out of 4 chance that the offspring will have white fur or will be homozygous recessive. And that again translates into 25%. Okay, well, that leaves 2 more. That leaves 2 heterozygous chances, or 2 chances for the heterozygous gene to be passed, which again will be brown fur. But for this one, there is a 50% chance that the offspring will have brown fur and be heterozygous. And that's 50% because that's 2 out of 4 showed up as heterozygous. Now that's the way we can relate that to science. Okay, but we're going to kind of move on, and we're going to talk a little bit more, whoops, wrong one, about the math part of it. Okay, So if you need to go back and watch that part, that'll be fine. Just go back and rewatch how we did that cross. That was just a quick little science review. What I want to show you today, though, and what we're going to talk about are the probability. How likely is it that something's going to happen? And what I would like for you to put in your notes along with this page is something called a probability scale. And I'm going to scroll down to the bottom of the page where I can use this area here. And it's going to look a lot like a number line. Okay? And this is going to be called a probability scale. On the far left, we're going to put 0%. On the far right, we're going to write 100%. And right here in the middle is going to be 50%. Okay? So if we take a look right up here, we're talking about probabilities can be written as fractions, decimals, or percents. And we've had quite a bit of practice of taking fractions, turning them into percents from a decimal. And we'll do just a little bit more of that. I think there's some more practice, especially when we get into the Khan Academy assignments. Okay? But I want you to focus on these terms right here. The ones that are in the little box over to the left-hand side. When we're talking about how likely is it that an event will occur, we use some terms. If there is a 0% chance of obtaining a possible outcome, or if there's no chance it's going to happen, we would call that uncertain. Or excuse me, not uncertain. Impossible. That's the term they use up there. It would be impossible. And the example for that is, think about a dice. If we were to use in most of your math books, they call it a 6-sided number cube, when really it's just a piece of dice or one dice. If we were rolling a dice and there are 6 sides on it, what is the likelihood that I'm going to roll a 7? Okay. Well, if you've got a dice and the numbers are only 1 through 6, the probability of me rolling a 7 is exactly 0, because there are no 7s on a 6-sided dice. Okay, that's one example. Move up here. We'll skip to this one. If you have an outcome that is 50% exactly, if there is a 50% chance, that would be kind of like if I have a penny. If I have a penny and I flip the penny, what's the likelihood that it's going to land on heads? Well, there's only one favorable outcome out of 2 possible outcomes. Okay, and that translates into 50%. So I have a 50% chance of flipping a heads or a tails on a penny. So it's equally likely as not. So it's just as likely that I am going to flip a heads as likely as it is that I'm not going to flip a heads. So sometimes we talk about that. We call it like a 50-50. There's a 50-50 chance. Okay? And then on the far right-hand side, 100%, if there is a 100% chance that something will happen or that we'll get a particular outcome, we say that that is certain. And that's the one right here. Okay? It is certain. Okay? And that would be the same. Let's go back to the dice. If I were to say, what's the likelihood that I'm going to roll a number less than 7? If I'm wondering what my likelihood of rolling a number less than 7 on an outcome on a dice would be, well, there are 6 numbers that are less than 7, and there are 6 possible outcomes or 6 sides on a dice. So a 6 out of 6 chance equals 1 or 100%. So those are those terms. Okay. Now what about the ones that are in between? What if we go back to the Punnett square, and it ends up that we are, I guess it should be a little more toward the middle. But what if our chances were 25%? Okay, so anything in between 0% and 50%, we call that unlikely. So it's unlikely that that event is going to occur. And I hope it's not too terribly jumbled up, but if you take a look, just refer back up here. If it's between 0 and 50, we would call that unlikely, any number. If it's 1% to 49%, it still is unlikely. It's not impossible, it's just unlikely that that event's going to occur. Okay? And then down here, if we go right in the middle, anything that is more than 50%, but less than 100, so from 51% to 99%, we would call that likely. If the number falls anywhere in between 50% and 100, we would say that it is likely to occur. Okay? So that's how we use a probability scale. And I'm going to post a better picture of one that's not quite as jumbled up as this one. I will post that in with your notes. Okay? I just wanted to kind of give you that. So I can get rid of all this. And then we'll move on up. All right, so now that we've got those terms out of the way, we'll talk about some of these practice. We'll go down here and do some of the practice. The notes that you see here are kind of like what I just talked about. It's turning those events into a fraction, okay? If you roll a number cube, which is a dice, what is the probability of rolling an odd number? Well, if you think about a number cube or a dice, there's numbers 1 through 6. There are 3 odd numbers, and there are 3 even numbers. So if I want to see what my odds are of rolling an odd number, or what is the likelihood of rolling an odd number, I know that there are 3 odd numbers on the dice, and there are 6 total sides. That's what that means. Number of favorable events is what is it that I want to look for, and the 6 is how many possible numbers are there total. Okay, so that's where those numbers come from. And you'll notice it just makes a fraction. You can say this 3 out of 6. Okay, 3 out of 6. That's what the little line means. And then that translates into, if you reduce that fraction, or if you simplify it, that's 1/2, which is 50%. So it's equally as likely for me to roll an odd number on a dice as it is for me to roll an even number on the dice. And we'll do lots more examples, especially with dice. That's a good one to do. Okay. The next example says your soccer team wins 3/4 of the time. Describe the likelihood of the event given its probability. Is it likely that your soccer team will win? Okay, well, that's where we're going to refer back to that probability scale. Remember, if you take 3/4 and turn that into a decimal, that's the same thing as 0.75 or 75%. Okay, so if you have a winning record of 75%, or if you've won 75% of your games, is it likely that you're going to win your next one? Well, since we're at 75%, yes, it is. It is likely. When it asks you to describe the likelihood of that event, you would say that it is likely to occur, that you are likely to win the next game. And I think I wrote 3/7, didn't I? Sorry. Okay, moving down. for the practice problems. It says you randomly choose one hat from 3 green hats, 4 black hats, 2 white hats, 2 red hats, and 1 blue hat. Find the probability of the event. In a problem like this, the first thing that you need to do is find out how many hats total you have. So we have 3 plus 4 plus 2 plus 2 plus 1. Is that all of them? Let's see. 3 plus 4 plus 2 plus 2 plus 1. Okay, so let's see. We've got 7, 8, 9, 10, 11, 12. Okay, so we have determined we have 12 hats total. And I would mark that over there in my margin because I might need to come back to that. So out of 12 hats, we are looking for what is the probability of choosing a red hat. Okay, well, we know that it's going to be a fraction, and 12 is going to be our bottom number because that's how many total hats we have. Okay, so we need to find how many red hats are there. Well, there are 2 red hats. So we would say we have a 2 out of 12 chance, or our chances of picking a red hat is 2 out of 12. If we simplify that, that turns into 1/6 or 1 out of 6 chance. And then I'm okay with you guys using a calculator for this part because hopefully by now you know that fractions are nothing more than a division problem. And that'll show us that there is a 17% chance. So it's 0.17 or 17%. There is a 17% chance of drawing a red hat. Okay, if I were to ask you what is the likelihood that you will pick a red hat, then you would describe that as being unlikely because it is between 0 and 50%. Okay, so for this, in this case, you are unlikely to choose a red hat. Next, what is the likelihood of not choosing a green hat? Okay, so we know that there's 12 hats total, and there are 3 green hats. That means if we take away all the green hats, we know that there are 9 hats left. Okay, we know that there are 12 hats total, and your probability of not choosing a green hat is 9 out of 12 because there are 9 hats after you take away those 3 green ones. Okay, and then again, we can reduce that, and that reduces to 3/4. Okay, so if we have a 3/4, if we have 3/4 chance or 3 out of 4, that translates to 75%. So you have a 75% chance of not choosing a green hat, choosing any hat other than a green one. And if we go back up here and look at our probability scale, since it's at 75, it is very likely, that you are going to choose a hat that is something other than a green one. All right. And then the last one, working with the hats here. What is the probability that you will choose a black hat? Well, we know there are 12 hats total. There are 4 black hats. We will say that there's 4 out of 12, or 4 out of 12 are black. So that translates into 1/3, or 1 out of 3 hats are black. And you have a 33% chance of choosing a black hat. Okay. Once again, we'll go back up here. What is the likelihood that you'll choose a black hat? And since it is 33%, it is between impossible and equally likely, between 0 and 50. So it is also unlikely that you're going to choose a black hat. Okay. Now, the very last one down here, this word problem, it says that there is a 20% chance of snow tomorrow, which it kind of feels like there might be a 20% chance of snow today. It's chilly outside. But it says that there's a 20% chance of snow tomorrow. So describe the likelihood of the event given the probability. Well, just like we've been kind of referring back up there, and we're looking at our probability scale, and we're looking at these terms here, we know that there's a 20% chance. So 20% falls in between impossible and equally likely, falls in between here. So we would say it is unlikely. It is unlikely to snow tomorrow. And that's what that means when those questions asked you to describe the likelihood of the event given the probability. You would say it's unlikely because it's on that lower end of the scale. Now, if I were to reverse that and say, what are the chances it's not going to snow tomorrow? Okay, if there's a 20% chance of snow, that means that there's an 80% chance that it won't snow. Okay, so 80% chance means that it's likely because it's in between 50 and 100. So it's more likely that it's not going to snow. So I hope that's not very confusing, but there's always two sides to the story. And I would say this is more the case. It's more likely to not snow than it is. Okay? So I hope this helps. When you're doing your homework sheets, refer back to this. Use these notes. Fill it in if you need to rewatch it again. Or if you have specific questions about your homework, please post those in the discussion board or bring those to us when we meet in our Zoom meeting at 2 o'clock. All right, I hope you enjoy your day. Stay warm and stay healthy.